Okay, let's get started. So today we're going to continue on writing my EVPN VXLAN Cookbook. And yesterday
Okay.
I learned two things. Number one, the roles option I don't think was going to get what I wanted to get out of building these configs. So I'm going to put the brakes on the role thing. The other thing is, after a glass of wine, I really have no patience for trying to figure stuff out. So I'm drinking tea right now. It's also a little bit early for wine. So what I've got, and just to give a quick introduction to everyone what I'm doing, is I'm writing an EVPN VXLAN cookbook for Arista EOS. I'm not doing this for Arista, but it's on the subject of Arista EOS. And the idea is to give configuration examples so people can use that for their production environments, for studying EVP and VXLAN, for learning it. And if you're going to take the level 3 exam, which very likely will include EVP and VXLAN, I don't know. I have taken the level 3 exam before, and I helped write part of it like years ago, but those versions aren't used anymore. So I have no knowledge of what the current level 3 exams are. Go away. So in all of the Arista ACE exams, so level 1 through 7, I'm level 7 certified, by the way. So all the Arista ACE exams are practical exams. So you actually go, you're given an environment of switches, and then you go and configure them. And you're allowed to bring in whatever tools or resources you want. The only thing you can't do really is, I'm sure there's other things you can't do, but you can bring in books. You can bring in blog posts and study materials and your own, even lab guides. So this is going to be a resource for that as well. So what I'm trying to do is come up with all these different permutations of different types of configurations. And I'm not going to type them all out by hand, because you can see I've got quite a few permutations going. And certainly not going to type them out by hand. So I'm creating different templates for each one of these scenarios, so it'll just build the configs for my environment. And when you build configurations from templates, you need a data model to supply the information for that template. So, and then I have let's talk about the objects I need to make for every type of topology. So what I need is objects needed to generate test configs. So of the types, so here's a couple types that I need. Number one, I need a template. So I'm using Jinja, and I've run into some interesting limitations with Jinja, and I'm wondering if I should start to try to learn Mako or Mako. I'm not sure how it's pronounced. It's a little bit more it's a little bit more Python-like. Now, Jinja is based on Python. It's got some Python logic in it. But I'm really, there's a couple of things I'm really missing from regular Python when I'm doing this. And one of them is functions. And the way that loops are done in for loops and if statements, the way that they're presented in Jinja is kind of difficult to work with in some cases when you get really intense. And I'll show you some examples. Another one, but I'm using Jinja for now. It's working for now. There might be a better solution. I might look at some better solutions down the road, but it's working for now. The next thing I need is a data model. Now I'm going to store that in YAML, and it's a completely self-made, homemade data model. I'm not using any Yang or whatever. I'm just using, putting in the fields that I need to populate the templates for the different devices. And I'm using one data model for the entire fabric. So I'm not using one data model per device. I'm using one data model that has all the information for all the leaves and spines to build out their configs. Next, I need a build playbook. So that's going to marry the two, to take the template and the data model, combine them together, and then give me a config. And then I need a deploy playbook. So that'll take the configs that were generated and then push them out to the devices. So in order to facilitate that, I've come up with a naming scheme that seems to be working pretty well. And it is bum slash, so broadcast, unknown unicast, multicast. How do I handle the flood frames? I'll just do flood. So I'm not typing bum. So flood, underlay, overlay, numbered or unnumbered, and then multi-homing. So for example, I'm going to do a head-end replication, so no multicast, with IGP as the underlay and IBGP as the overlay with MLAG. The naming convention will look like this. So HER, IBGP, IBGP, MLAG. Or if I was doing head-end replication, OSPF unnumbered, IBGP, and all active, EVPN all active, it would look like this. So HER, OSPF U for unnumbered, IBGP, all active. So I'm using that as a convention to name the files, name the directories, and all that. And it seems to be working out. So let me show you what I've got so far. So here are my templates. And these are the ones that I've created so far. So head-end replication, EBGP, EBGP, all active. So EBGP for the underlay overlay, that's the default that Arista uses. I've also got IBGP as the underlay and overlay. I've got OSPF numbered as the underlay and IBGP as the overlay. I've got OSPF unnumbered as the underlay and IBGP as the overlay. And OSPF unnumbered and then MLAG. So that's what I'm working on right now. Where I really ran into problems with the looping that I had to do. I mean, look at this. Look at this mess. This would be a lot easier if I did this in Python. It would be a lot more clear. It actually wasn't all that difficult, but just keep like, where does which loop end and which loop begin? And I thought about trying to like indent, but then it adds all these weird spaces in. So there's lots of nesting that I'm doing in order to get the information that I need out of the data models. Like, let's see if I can find the for statement and for, yeah. So this right here is building my neighbor statements for BGP. And it's a little bit tricky because it's eBGP, so I need to know what the AS numbers are. So basically I'm going through each device, their point-to-point links, finding out what this particular device's first point-to-point interface is, what its IP address is, and then we're subtracting one because I'm using the leaf as the lower or as the higher address. So, or the lower address. So if the spine is the higher address, then I need my neighbor to be my address minus one or whatever it is. So I had to go through all that, and it was pretty gnarly. And because there's no indentation, I don't know where the nests are. And eBGP was the worst because if we look at the configs that are generated, not only do I need to know the IP address of my neighbor and have to figure it out from the data model, I also have to know the AS number. If it's a leaf connecting to a spine, I've already got a data model that just says what's the spine's ASN. But if it's a spine, then I need to know the individual AS numbers of the other ones. So I have to basically. Now, if I wanted to, I could probably just put it directly into, I could be like, And then put another one is E3 neighbor is 65 or whatever. So I could put that in there. But it basically has to loop through each of these devices, find the IP address, and then reference the AS number. So it's not very difficult to do. It's just not very clear when you're doing it with Ansible, or doing it not with Ansible, with Jinja, because of the way that they represent loops. So I think that might be a case where Mako or some other templating engine might be better. But I don't really want to try to learn a new one. And this is working enough for now. And this is the BGP, eBGP is the most difficult, and I seem to have gotten my way through it. So, so next up is, what am I doing? MLAG. So OSPF unnumbered. I think that's what I've got running right now. So if I want to bounce between the different topologies, I can run this deploy playbook. Deploy HER OSPF unnumbered MLAG. So this goes through and pushes those configs. And you can see I've got it's IP unnumbered. Show IP OSPF neighbor. So we've got the MLAG neighbor relationship done. So that's over the peer link. And I've got OSPF going with the spines. And if I do show BGP EVPN summary, okay, so we don't have that on here. So what? All right, so it looks like I got to figure that out. Let's try all active. So I think that one might be OSPF. No, yeah. So it looks like I need to fix this. My template does not build the overlay. So I got a little lost of where I was going in some of these. Yeah, so there's no BGP section for the overlay. So I need to add this here. I'm going to steal it from iBGP overlay because it's the same config. Because OSPF, iBGP, iBGP, iBGP. So the overlay in both of these is going to be it's going to be nearly identical, although the MLAG is going to throw a wrench into that. So let's go ahead and do that. All right, so I'm just going to copy all of this. This is the BGP config. And put it into IP unnumbered. And where did it go in the config? Was it before or after? After that. Yeah, I think it shows up before OSPF. So we're using OSPF as the underlay, IP unnumbered, and we're using iBGP as the overlay. This is the way that they tend to do it in the Cisco world, although they tend to do multicast for the bum frames instead of head-end replication. But head-end replication is a lot simpler. And it works better in some environments just because it's simple. But if you have a really big environment, it's probably better to go to a multicast. Otherwise, you like every leaf when it generates a bum frame, it's got to send a single copy to every other leaf, and that can mean like if I've got 100 leaves, I have to send 100 frames, one to each device or one to each node leaf. So that can get a little crazy. But we're just going to do head-end replication for now. If you do EVP and VXLAN and you're listening to this in the chat, could you tell me what you use for your underlay and overlay and whether or not you use MLAG or EVPN all active or multicast or head-end replication? I'm curious. So tell me what you're doing in the chat room. What's your EVP and VXLAN environment look like and what vendor is it? All right, so So this should all be good. We can take out the underlay part because we're not doing anything for the underlay. So I'm going to remove all that. And then we don't have any address family IPv4 when we're using OSPF as the underlay, and it's just EVPN. Then we do have to generate the VRFs for the VLANs. We're not using, I'm not using EVPN aware bundles just yet. It's easier just to loop through the list of VLANs. So the EVPN services is right here. So these are the VRFs, the VLANs, etc. I'm also going to have to do something about whether or not we're going to do IRB, symmetric IRB or asymmetric IRB. I don't really see any asymmetric IRB out there. It's just easier to do symmetric IRB. The configuration is actually simpler if we do symmetric IRB. Concepts are a little weirder, but it makes more sense, I think. There's a little tea drinking ASMR. I'm drinking Tazo tea. It's orange. My friend got it for me. She might be watching. All right, so let's. So now I've done that. Now I need to build. See what comes out. And so, do I have a deploy HER? Yeah, I do have a deploy script. So this is what my deploy playbook looks like. I put everything in fabric type, so that encodes all the things that I want. So head and replication, OSPF unnumbered, IBGP is the overlay, and then MLAG is my multi-homing. And then that gets declared as a variable, and that way my config directories, my config names, they're all consistent. Oh, we need to build one, not a deploy. Same thing. So I just put that in there, and so build. Yeah, that's the right one. So Ansible playbook, build, HER, OSPF, unnumbered, IBGP, MLAG. Okay, so it's got some errors. No attribute, IBGP AS. It may be that I don't have this as a variable file. And I do. So make sure that matches. HER, OSPF, U, IBGP, MLAG. So I do have a variable file. And, oh, I didn't put in the... Yeah, so IBGP AS is going to be 65,001. All right, so try that. Okay, built the configs. Let's see what kind of configs we got. It's a lot of work up front, but once I have all the templates built, then it's just, I can bounce around between the different topologies very quickly, very easily. All right, so let's see, I'll just give it a sniff test. It looks like it would work. I don't see anything wrong. So let's give it a deployment. Let's give it a tasting. So we're going to deploy it, and we'll see if we get any errors. It looked like it deployed, and it looked like it found everything it wanted. So deploy. Yeah, I think I already maybe had this deployed. Oh, I need to build first. No, I did build. Yeah. All right, so leaf 1, show IP OSPF neighbor. Looks good. Show MLAG. Consistent active. Show BGP EVPN summary. And establish. Okay, so we're good. So that one works. So that's good there. And then what's the other one I want to do is all active. So build HER OSPF on, yeah, I don't have one for all active to build. So I'm going to create a new build playbook. I'll copy this. So build, head-end replication, OSPF, unnumbered, IBGP, all active.j2. Rename this to, yep, I think that's what we need. Or ASMR. So build, so that's unnumbered, IBGP all active. Oh, I didn't, what's this one doing here? It's a J2 file, that's a wrong place. So this is OSPF. God, it's easy to get this stuff mixed up. IBGP unnumbered, all active. So I need to build HER OSPF unnumbered IBGP all active. Okay, so we don't have one yet for that. So we'll just copy. And because I'm keeping it consistent with only changing this, this makes this a lot simpler. Okay. So let's see if we can build a config that way. So Ansible playbook, build, HER, OSPF, unnumbered, IBGP, all active. All right, didn't like that. So this usually means it didn't find a data model that matches this name. And it didn't because I didn't name it correctly. So it's got to have the U for unnumbered. All right, I found something else I didn't like. Oh, it doesn't have a directory. So I need to make that directory. I didn't automate creating the directories. Maybe I should do that at some point. So configs, HER, OSPF, unnumbered, IBGP, all active. All right, there we go. So now I've got OSPF unnumbered, IB all active. I've got some configs, and let's see if they work. So now I need to deploy. So deploy HER, OSPF unnumbered, IBGP all active. And I'll just copy this. This is my deploy playbook. And paste there, and I'll just change this right here. That's all I have to change now, the way that I'm doing this. OSPF unnumbered, IBGP. Because this variable is called in all these different places. So I'm keeping things consistent. All right, so that deployed. No errors in the config. That's great. IP OSPF neighbor. All right, so this did not include the underlay, or sorry, the overlay. So I've got to copy and paste that. So that should not be too big of a deal. Unnumbered, and I'll just use the config over here. Just copy this, paste it into the template for unnumbered. Build the config again. All right, IBGP AS, same thing. I just need to make sure that I put the IBGP AS in there. Under global options. So this data model, I'm using mostly the same data model, although the data models are a little different. So for example, For IBGP, I have to specify the IP addresses. And for unnumbered, I don't. So there's just a list of the interfaces that are point-to-point. But for numbered, I do have to specify the IP address, which is kind of annoying because I don't like the... I'd rather just be unnumbered. One of the ones I'm going to make is... Oh, crap. BGP unnumbered. So do I have to rename all these? I think I have to rename all these. So that should build now. Okay, so that worked, and then we'll deploy. Okay, so nothing came up there. Show IP interface brief. Show run. Section BGP. Oh, there's no... Yeah, I'm missing something. Yeah, the address family activate that's missing. So where did that go? Getting real tricky to remember all this stuff. No, it should have been in there. So MLAG is fine. It's all active. That is not. What is missing? Oh, that's in there. No, it is in there. So why is it not? Oh, it is a step. Never mind, it's there. Yeah, that's show SPF neighbors. Okay, so that's good. Keeping track of all this is getting a little difficult. All right, so that's that, and then we need numbered. Did it have a numbered one? Where'd it go? Yeah, so do I want to do a numbered one? Yeah, let's go ahead and do a numbered one. So I'll do fabric HER OSPF numbered IBGP all active. That's the simplest one to do. And then I need a vars file. Well, that's is vars file. I'll need the template. Looks like I do have one. So the numbered one, I'm going to use the one from BGP. Paste it into numbered here. I've got to number all these. This is the tedious part. right, so this is OSPF. So I can't use /31s for OSPF. I have to use /30s, which is a pain to do because of the way that I segmented everything. So I'm just gonna make a table here. No, do I want to do that? No, let's try this. All right, start from the spine, so that'll be 1/30. Nope. Do a text slide. So E3 10 1 252 1/30 30 1 252. I should have had a program that would. I can write a Python script that would just generate all these. So 0 1 2 3 4 5. 9. 14, I think. No, it'd be 13. Yeah. Let's get rid of these. One of the nice things about Arista's AVD is that you can just give it a block of addresses and it'll chop it up automatically and assign them dynamically to the interfaces. I'm not that sophisticated here, so on leaf 1, we just have Ethernet 3 and 4, and then that will be the opposite there. So I don't know what that one will be. Six. 10 and 14. So 13, 14, 15, 16, 17 is where we start over here. Be 21, 25, 29, I think. Let's see. So 18, 22, 26, 29, 30. Okay, that looks like that will work. So I'll just put them in here. I will replace all occurrences /30. So leaf 1, that's 2, and then 18. Leaf 2, that's 6 and 22. I've just got this in the other screen. Don't have room on the screen to put both. 10 and 26. 14 and 30. Then here, it's 1, 5, 9, 13, 17, 21, 25, 29. All right. So that's for OSPF numbered. Do I have a build one yet? I do. So let's try to build it. OSPF numbered. Okay. Make the directory. Configs, HER, OSPF numbered. BGP all active. All right, so it made a config. You can see that we've got IP addresses on these interfaces. Let's try the deploy. So I'll just copy, paste. Bring this numbered all active. And then we'll try to deploy it. I like it when that happens. So I've got, it is numbered, show IP OSPF neighbors, nothing. Okay, show run. Why nothing? I'm on leaf 1, I should be able to ping 10.1, 252.1. Can and 17, and I can. So at least the numbering I got for between leaf 1 and spine 1 and 2 are okay. Oh, there was no OSPF. This is nothing configured for OSPF. Because I think I used the wrong template. Yeah, there's no. So I'll find unnumbered, and I'll put in the put in the OSPF part. It's pretty simple. And then for these, I just have to put in the IP area. This part. So it puts in that, and then for the loopbacks, put that in there too. So build, deploy. So OSPF is up, show IP, show BGP EVPN summary. Okay, so that's not up. So why not? Oh, because I just have the underlay part in here. It's the cutting and pasting that's... So I just basically need this part. I'll just recopy and paste it. Copy. Just overwrite this entirely. Paste. Build. Deploy. Established. Cool. That one's out of the way too. The next one I want to do is I do head-end replication with eBGP unnumbered. So I'm going to copy this. and then paste it and rename it. So headed replication, eBGP, and then I'll need a data model for that. I'll just reuse this one. And then here, I'm going to go back to the list of Ethernet 3, Ethernet 4. Because with unnumbered, BGP unnumbered, Ethernet 3, Ethernet 4, we used RFC, basically we use IPv6. And we use link local addresses and neighbor discovery to dynamically configure BGP neighbors, which is really cool. We still need to tell it which of these interfaces are going to be our point-to-point links. Point-to-point links are the links between the spine and leafs. And we don't need IP addresses for them. All right, so, and then the here's the Thunderdome here. What is yeah? There's a couple commands you need. Well, first of all, let's do the interfaces, because the interfaces are going to be a lot simpler. We don't do that. We just do this IPv6 enable. That's all we need to do. There is 2 commands we need to enable for IPv6 routing, and then IPv6 interface something. I can't remember what it is, which is why I'm going to look it up. Now, what I'm kind of annoyed by is that I have an account, but I cannot I don't have access to these resources, so that kind of stuff I cannot do. But on community it does. It allows me on that. There's 2 commands I need to enable. Just trying to remember what they are. IP routing v6 interface. That's the one. Okay. There's show run grep routing. another command too. There's two commands. I think it's a normal IPv6 routing config. IPv6 unicast routing, that's it. Okay. IPv6 unicast routing. Show run grep IPv6. One just enables routing for IPv6. The other one enables IPv4 routing over IPv6, I think. I think that's what it is. Just I remember there being two of them. And I need to know where in the config they go. Now, theoretically, I could put these just about anywhere, but I want to put them into a relatively good place. Oh, shoot. Did I put this in the wrong place? Yeah, I did. So this... Yeah, so this is the unnumbered one. Man, I'm going to screw that all up. IPv6 enable. That's all we need. Then IP... Where's my route? Goes right above here. IP routing. IPv6 interfaces. Then after this... IPv6 unicast routing. Okay, that looks good. Here's the mess. So the network statements, the neighbor statements aren't IP addresses anymore, they're just interfaces. So I'm just going to configure spine 1. So run interface E3. So I'm going to do this. Interface E3. No IP address. No this. No this. Then of course IPv6 routing are, what were they commands? Unicast routing and IP routing, IPv6 interfaces. Okay, so this is the link local address that Ethernet 3 got, and it's based off of its MAC address. So for leaf 1, show run interface E3. Interface E3, no IP address, no this, no this, IPv6 enable. And then, yeah, so show IPv6 interface brief. That's my link local address. Show NDP, IPv6, NDP. So here's how it found it. It's neighbor discovery. So it's sent over a multicast, and they're able to sense each other like Highlanders. And I'm going to take a break real quick because I want to get some more tea. And I need a bathroom break. BRB. All right, well, I'll come back. So my tea is, my kettle's heating up the tea right now. So in, well, you know what I should do? Should have done this first. Is deploy the BGP. All right, so now show IP BGP summary, EVPN summary. So that's all established. Unfortunately, I just erased all the work I did, so I've got to do, because it replaces the configuration entirely. For example, if I look at E3, I just configured it. Now it's unconfigured, but that's okay. But the underlay is numbered BGP, and we're going to convert it into unnumbered BGP just to get a sense of what the config needs to look like, because I forget some of it. V6 unicast routing, interface E3, no IP address, IPv6 enable. And then same thing over here. IP routing, IPv6 interfaces, IPv6 unicast routing, interface E3, no IP address, IPv6 enable. So again, that's our link local address. All right, so so this is the neighbor statement here. So no and no. So now it's neighbor Ethernet neighbor interface Ethernet 3 peer group underlay remote AS 65101. Right, that's interesting. So my syntax is going to be different. So I'm glad I did this. This is a huge, this is a big tour of all of the all the config. So neighbor interface E3, because it's the same on both sides for belief 1 and spine 1. Peer group. So this is the old syntax, which is interesting. I wonder if it's changed for the newer versions of EOS. That could be an interesting issue if I run into that. And this is peer group underlay remote AS 65.1. So show IP BGP summary. And look at that, we're established. Now, but you notice we're not receiving any routes. So we have to fix that problem, and that's because we didn't enable anything in address family, IPv4 and IPv6. I can't remember which goes to which. I've got a config here. Look at someone else's config. Yeah, so BGP next hop address family IPv6. So that's, I think there is another command in there too that needs to happen. So BGP next hop. That's not correct. Nope. It's all messed up there. Do I even need to do... one thing I can do is I can just look at what AVD generates. What is it? I love AVD. I would be using AVD for this, but I need a very bare bones config, and AVD does put some stuff in there that isn't relevant. And there's actually some combinations that AVD doesn't support. For example, it doesn't support IBGP as the underlay and overlay. And then generating all the different data models to do all this, I think would actually take more work than what I'm doing, although that's kind of debatable at this point. But I normally would use, I definitely normally would use AVD for production. This is just a learning tool. But the cool thing is that AVD can generate these configs pretty quickly. If I forget how to do something, like I forget how to do RFC 5549. Underlay RFC 5549, yeah. Just make that true. Build out the fabric. This is a huge topology I made. It's got 50 leafs, a bunch of stuff. So I actually did a speed run of this not too long ago. Intended configs. Leaf 1 config. Yeah, that's it right here. Next hop, originate. So that's what we need to put into this. Unnumbered. Make sure I'm in the right place. Neighbor, underlay, next hop, address, family, IPv6 originate. Yeah, we don't need an address family IPv6. Excellent. All right, so let's try building. So I have a... Nope, I need a build playbook. didn't like something. No attribute Ethernet 3. Oh, I think it's probably because we're doing a list instead of a dictionary. So that's in the template itself. All right, so here we're just going through the list. So that should be fine. So let's look up P2P. And yeah, here's where we normally, this is where we had to do all that math. that really annoying math. So, oh God, how am I going to, I'm just going to start over. See, this is why this is why I was having so much trouble with, look at this mess. There's no indentation to tell me what level of nesting I'm doing. Clearly, Jinja was not meant to nest this much. All right, so what do I need of the commands? I need neighbor interface. Okay, so we can get rid of this command because it doesn't matter. No, we can't. Oh, crap. I gotta just start over. I've got it in another one, so that's okay. Then this stuff will be fine because that's EVPN. So, show run section BGP. So we have to include both things on both lines. We don't need to know the IP address. That's fine. So it's we're going to loop through for interface for P2P in devices, inventory host name, P2P. So that's fine. We'll do N4. Let's just do this. We'll do P2P, generate. Oh, we need to generate the directory. Cool. So that means it was fine with that template. The template's not going to work because it's not correct syntax, but HER, EBGP, U. There we go. Let's see if it just gives us the right interfaces. Man, there was a lot of permutations here. Yeah, it looks like that's correct. Okay, so then it should be neighbor underlay interface. Or was it neighbor underlay interface? What was it? Neighbor interface. P2P. Peer group. Underlay. And then we have to have the remote AS. This is where it gets tricky. Because I need to find out what the remote AS is. And because we're doing EBGP, if I'm in the leaf, I know that it's pretty easy to find out. So that if, we'll do an if statement here. So if leaf in inventory host name we'll do end if. Then this remote AS is just the it's just the spine. It's in it's just this spine ASN, global option spine ASN. So I can see that in my leafs. That's not a problem. The problem is when I'm the spine, I need to find out the individual one for each leaf. So what the other end is. I could match it on IP address before, but I can't now because there's no IP address. So how do I know what I'm connected to? Oh, this is a problem. All right, I'm gonna make my tea. Be right back. All right, I'm back with my tea. Another thing I'm going to do on YouTube right now is I'm going to upload a quick video because I helped a guy out, helped a person out. All right, so that's uploading now. All right, so I'm back. All right, so I need to know what the remote AS is on these devices. So how did I figure it out here? Because they were the loopbacks. Did I match on loopbacks? No, we just loop through the loopbacks. So the problem is, in terms of the information that I have, is I've got on my spines, I've got 4 interfaces currently that are plugged into leafs. how do I know what the AS number on the other side is? And I don't really have any way to correlate that right now. So I'm missing, I don't have sufficient information in the data model is the problem. So this can happen. So sometimes I can use some logic to figure it out, but right now I don't have enough information to even do the logic. So I might have to change these to... I might have to change these to the other side's ASN. Not liking this as a solution, but maybe what I got for now. Or maybe in the shower I'll think of something that's a better solution. Or can I just do a peer group? Oh, you know what? I could do a peer group. Yeah. I could do a peer group. So, or not a peer group, a, what's it called? So, BGP config Arista, forget what it's called. It should be in here. Pool. You basically, instead of doing an individual neighbor, you allow connections from a number of IP addresses and ASNs. But can I do that from an... Oh, shoot. That's probably not a good idea. For IPv6, at least. God, I can't remember what it's called. Something you can do on the spines. So we figured it out from the... Oh, I think I used it in a template a long time ago. So let's find out. I'll use my own work. Maybe I did it in here. Templates. Yeah, I think I did it in the spine one. Listen range, that's what it is. BGP listen range. So you can specify a set of ranges of IP addresses that can come in. Let's see what we can do. So I can do prefixes. The problem is I'm not securing any of this stuff. You know what? I'll go ahead and do this. FE80. What's the link local? What's the mask for link local? Yeah, I can do this with the listen range. So this would be done on the spine. Pure group. Underlay. I need to do a peer filter. And call it underlay filter. Match AS range 65101 to 65199. Result, accept. So when I have to put filter range in there, I really should put some security stuff in here too, because it's the exam could have you try to secure it. So many permutations. Another bathroom break. Be right back. All right, back. The tea kind of went right through me. All right, so I can throw a peer filter in there. That's fine. So I will need a new piece of information in the template or the data model. So data model will have leaf ASN range. So it'll be a string there. Because I'll need to generate that. All right. So the if it's a leaf, then it's easy. So if we're a spine, I'm also determining whether or not I'm a leaf or a spine by just what's the name of the node. I could also use a type, just put a type variable in there, but I think this will probably be just fine for this. So neighbor, so BGP listen range. And then that'll be under global options. What did I call it? Leaf ASN range. What's the command? Oh, I don't need that just yet. In fact, we know what it is because it's link local. Well, the question is, will this work for IPv6 unnumbered? I don't know. We'll call it underlay. So that's BGP listen range. What did I call it here? Underlay filter. It seemed to work. Although I think I still have a neighbor statement in there. Show run. Yeah, still have a neighbor statement in there. So now we're passive. We're waiting for the other side to establish. So this might not work. So I'm trying to connect. Oh, I did FF80. I did the wrong listen range. Yeah, so that's why. Listen range FE80. Peer group, underlay, peer filter, underlay filter. Yep, that worked. Okay, so it does work. Sweet. All right, that solves that problem. You know, one of the toughest things when we're making these choices is we're kind of locking ourselves into a lot of, not really locking ourselves, but anytime we make a choice like that, there's always a cost in undoing that choice, unwinding that choice. Sometimes it's not a big deal, and sometimes it's kind of a major deal, but this should be fine. And then I just need to figure out where the peer filter goes in. Where do I stick the peer filter? All right. Put it there. Right here. What was the var leaf ASN range? All right, so let's try to build this. See if we get a, okay, built. Let's try to deploy it. Oh, we don't have a deploy script. Okay, so we'll make one. Okay, so it didn't like token 5 interface. So it got some errors in the config, so they didn't load up right. So it was oh, I said interface twice, that's why. Yeah, that shouldn't be in there. Build, deploy. There we go. How the heck is that working? How are they established? I don't even have routes to them. They must be... Yeah, okay. So should have, so Ethernet 3.4 peer group underlay remote AS 6501. Why do I only have one attempt? Peer filter underlay. Oh, because I gave it the wrong name. So that didn't match up. So now it shows active. Connection rejected. So what's my filter look like? Oh, did the wrong one again. Should be FE80. Deleted the wrong one. There we go. Now we're established. But we're not getting any routes. Show IPBGP. I'm not getting the... Oh, there we go. Just took a second. There we go. All right, so that is good. All right. So got another one down. Oh. All right, so we got that going. What else do we need to do? Probably do this one with MLAG. So this will probably be the most common one, is eBGP with MLAG. In the data center world, I noticed that Arista tends to recommend just MLAG versus EVPN all active. It's a little bit simpler to troubleshoot. It's a little bit simpler to configure than EVPN all active. and usually the troubleshooting skills that you might have brought over from a non-EVPN network will translate into that MLAG. A lot of the advantages of EVPN all active aren't really that great. For example, it's multi-vendor, but who cares? I'm not. I've been trying to do a Franken fabric with 3 different vendors, and it's a lot. It's more than double the work. So just having 2 vendors is like triple the work. Having 3 vendors is 5 times the work. Because then you have to build a Rosetta Stone for all the different show commands you want, and you can't. It's hard to keep them all straight in your head. So a data center fabric, at least, we're typically just one vendor, unless we're like transitioning to an old vendor and we're trying to integrate them. But that gets complicated. So, and even then, if you're doing MLAG, or let's say I've got Cisco and they're doing VPC, and then I want to migrate from that to Arista with MLAG, that's okay because you can have both on the same network. The only restriction for MLAG or VPC is that the 2 switches joined together have to be the same vendor and the same model. The other advantage, whereas with EVPN all active, they can be any vendor and any model. The model part's a little bit more flexible than the vendor part. But the other thing about it is you can connect to more than 2 devices. But most of the time, the way that racks are hooked up, each compute node is only going to be able to connect to 2 leases anyway. So, but in the Arista world, MLAG is pretty well trusted. I know some people don't like MLAG in general, or at least the concept of it. But in the Arista world, it seems to be pretty solid. I haven't really heard of too many problems with it. Juniper seems to be different, though. I've heard a lot of people talk about Juniper's MC lag implementation just not being very good, and people being screwed by it a couple of times. So then in the Juniper world, they tend to do all active. Cisco typically just does VPC, kind of the same thing with Arista. It's pretty well trusted. But yeah, we'll see. All right, so let's do MLAG because it's going to be the most common. Now I do need some oh yeah, MLAG. I got a peer. So I need to add these in there. So we need to create the peer links first. So I'll do the peer links, and I'll use the template here for the peer links. Yeah, so there's a couple of things. Oh yeah, I put some logic up here. So I put some logic up here, and what it does is if we have a leaf in the host name, and we're gonna figure out whether or not we're an even leaf or an odd leaf, and because that'll come up later. So I'm gonna put this at the top of this template. So before we get to any configs, we're just gonna do a quick little check. Are we a leaf? And if we're a leaf, which are we, an odd leaf or an even leaf? Because the configurations for MLAG on Arista is identical on the left side for all devices on the left side and identical for the devices on the right side. So we just need 2 different MLAG configs. So we need to determine which one of the templates we're going to use, or parts of the template. And then we also do a spanning tree VLAN ID there. And next up we do, so that's that part. And then we create the VLANs, because we want a VLAN. Yeah, we have to do a level layer 3 one. That's going to be kind of annoying. So create those VLANs. Did I put... Yeah. Just want to check something here too. Oh, I got to do both of those. Got to disable both of these, and where is that done? Spanning tree. We should set spanning tree in this too. There's a misconception that spanning tree is not used in EVPN VXLAN. It is on the Leafs, and it's not because we're going to block a port in normal operations. It's in case we plug, like, unless we plug a leaf into itself and we accidentally create a loop. Or we plug a leaf into another device and that other device also plugs into the same leaf. So we still need spanning tree. But we're going to disable it for yeah. We're going to disable it for the MLAG VLANs. There's two of them, one for layer 3 and one for layer 2. And we only do it for the Leafs. Spanning tree VLAN. We need two of them. So I'm going to load up this in the right screen off to the side. I can't remember what the... All right, that's what we want there. All right, then we want to create the port channel. So that's after AA authorization. Where that is. Then we create the peer link off of those. Mode active. Loopbacks management. Then we need to create this VLAN interface here. Where does that show up? That shows up after management 0. So this is an SVI used for the peer VLAN ID. And then I need this one too. But this one's not going to be OSPF. I do need an IP address for this. Crap, what am I going to use? I think I hard-coded it in last time. Am I using unnumbered in this one? I've already lost track. No, I'm not using unnumbered. Okay. What does AVD use? I can't remember. Loopbacks management. All right, there's the SVIs. Yeah, I used IP numbered there. Oh, so I got to give it. That's. Can I get away with just using the same IP address? Let's find out. So 0, 1, 2, 3, 4, 5, 6, and 7. Let's try that. All right, let's try to build that config. So I need to build. I need to build. I need a build for this. I'll just copy, paste, and rename it. I'll just change this to mlag. I do have to make sure the directory exists. And then I can build the configs. Woo, I barfed on that. Let's see what we needed to fix. Maybe a couple of things. Oh, crap. See, this is one of the more tough ones because I didn't close off an if statement. So at least I know it's an if and not a for loop. So I need to figure out where I messed up and didn't put a loop, close a loop, or close an if statement. So let's go check out all the stuff I added. So if, oh, maybe it's here. Because I have one if, two ifs, one end if, two end if, three ifs, and one end if, or two end ifs. So I think I need to do another end if here. Let's try that. Nope. Well, I did need to fix that. So 1, 2, 3. 1, 2, 3. So maybe there's others. If and if. If 4, 4, and if. Okay. If 4, 4, and if. That looks good. if and if, for N4, for N4, for N4, if and if and if. All right, here's another one we're missing. So 1, 2, 3. Okay, so different error. Side is undefined. We defined it here. So if leaf is in the host name, we're going to set leaf number. And if the leaf number is modulus 2, we're a side even or side odd. We definitely needed to do that. It was in the spine. Oh yeah, so I need to put a thing, are we a leaf? So look for a side. Yeah, because we didn't put a conditional. If leaf in inventory host name. And then end if. There we go. And then we need to deploy. So I'll just copy that. Did I use this right one? Yeah, I didn't actually put mlag in there. mlag configuration, so I did put that part in here. Don't think I did. It's a mess over here. Yeah, so let's put that in. Okay, didn't like leaf 2 and 3. All right, I got the IP address wrong. Yeah, these are wrong. So it's a /30. So 0, 1, 2, 3. Then the 4, 5, 5, 6. That's what it is. 5, 6. All right, let's see if mlag is connected. Connected. All right, mlag looks good. Cool. Let's show IP BGP summary. Show BGP EVPN summary. Oh, good. They're established. Another one down. I think I might call it a day. So I've got, these are all of the different variations that I have going right now, which is pretty interesting. And I can just bounce back and forth between them, which is pretty cool.